Good morning. This is Vignesh.
Morning, Vignesh.
Hi, Mo. So today we are going to talk about learning outcomes in course learning outcomes that we typically write in an undergraduate one semester course. What do we mean as a learning outcome?
Um, I guess learning outcome is something that happens in the mind. The process of learning takes place in the mind of the learners, and the outcome of the learning process also exists in the mind of the learners. So it could be a skill such as, for example, riding a bicycle, or it can be an ability as the ability to write an essay, or a capacity such as capacity to do research. Any of them.
Okay, but we don't do learning by cycle riding and doing research in an undergraduate
That is true.
program.
Yeah.
So we'll have to take in some examples of typical learning outcomes that are phrased in an undergraduate
In
curriculum.
undergraduate first year.
First year or second
Okay.
year. So let me give you some examples of that. So for instance, suppose I say one of the outcome of a particular course is to understand big data and real-time application in various fields. So what do you think is the learning outcome here?
Understand and apply.
Yeah, understand and
Yeah.
the application of it in
Yeah.
various fields.
So
Yeah.
I don't know the exact details of the application, but I can speak in general terms about understanding and application. These are good learning outcomes provided we are aiming at the right kind of understanding and the right kind of application. So there is for example, if you're going to primary school, let's say multiplication addition, there is a level of understanding and level of application that can be done without thinking. So students may not understand arithmetic operations, but they can still execute the applications so that they can answer the questions in 2 minutes if you give them a problem. That's the lowest level of application possible. So we have to make sure that, well, that is also a learning outcome, right?
But
Is that what we are expecting from undergraduate students? That low level of robotic application?
yeah, that's one question to think about. The other question is, see, as educators, we are also supposed to assess the students.
Yeah.
So if understanding is something that happens in the mind, as you say,
Yeah.
then we don't have access to it.
No, but we have access from the behavior, indirect access. I mean, if you can observe the behavior and make an informed estimate or informed guess about what exists in the mind.
Okay, so
Yeah.
so when you say like, let's take a school kid, a school kid doing multiplication of two multiplied by 2 is 4. The student is able to tell the answer that 2 multiplied by 2 is 4.
Yeah.
Then we assume that the student has understood the concept of multiplication.
Well, is that legitimate to make that assumption? Or how do you know whether the student has sort of internalized the mechanical application like a robot? For example, a calculator can do the same thing. The calculator has no mind, no thinking ability. How do we know whether the student is not functioning as a pocket calculator?
Yeah, so isn't that the flaw or limitation in the design of an outcome-based assessment?
It's not a flaw in the idea of outcome-based assessment. It's a flaw in the way people implement it. So you should know how to ask questions in such a way that it gives you a better measure of what exists in the mind. And this is what scientists do, right? They look at behavior and make an assessment, make guesses about the system.
Isn't it also a flaw in the way the outcomes are formulated?
I guess, yes. Oh, by the way, this is Tara. Yes, it is the way the outcomes are stated in the outcome, the syllabuses, right? It can be stated in such a way that you don't have misapplication of the idea of OBE. So if you just say understand and apply, it doesn't prevent mechanical application. It has to be made precisely such that such questions will not be asked. Maybe you should give examples. right?
Yeah.
Yeah. Then it might probably be, and levels of application.
So if I take the simple multiplication example, so what would be a better, or what would be a good one? How do I rephrase my learning outcome, or should I rephrase my learning outcome? Two, what would be a better way of assessing if the kid has really understood multiplication, not the mechanical operation?
Yeah, yeah. So one thing to do is not give the way questions are, not formulate the questions in such a way that a pocket calculator can do it, right? Give in terms of numbers and the symbol of multiplication, symbol of division, so on, which is easy for the pocket calculators to implement. But suppose you ask this question. In fact, this is a question that we have asked kids. Let us say there are 20 grapes on the table, and Tara has eaten 3 oranges. How many grapes remain? And 6th grade kids, may say, for example, 17. They don't know how to model the real life phenomena in terms of the mathematical model of whatever, arithmetic operations. So they just know, oh, maybe you should divide, maybe you should apply, subtract, add. So when we asked them, subtract, and they added or they multiplied or divided randomly. Now notice that a pocket calculator cannot answer the question that I formulated. So you should formulate questions in such a way that pocket calculators do not, or ChatGPT, if that is the case for undergraduate education, cannot answer.
Okay, I think I get that point. So what you mean to say is the design of the assessment we should do it very carefully, such that we also know what we want the students to understand, and the assessment is designed to test that.
Yeah.
Okay.
So for example, if you had said conceptual understanding of arithmetic operations, which is not possible for pocket calculators, then there is a kind of hint there that you can't behave like a pocket calculator.
Right. Okay. And what is your take on the Bloom's taxonomy verbs that that is widely used today to write questions, frame questions based on the Bloom's taxonomy verbs like analyze, apply, perform, evaluate?
Yeah, all these have the same problems. Analyze can be, the word analyze can be interpreted to mean, for example, identify the parts and label the parts. This is what we meant by chemical analysis. You take a compound, you identify the 2 parts of it, label them, then your job is done. This is something that a machine can do. You can also do this, for example, analyze the structure of a flower. What it means is that identify, the parts of the flower, label the flowers. That is one meaning of analysis, break down and label. But there is another meaning of analyze, namely, for example, philosophical analysis. That is not breaking into parts and labeling them, but thinking about the process. And philosophical analysis is not possible in a multiple choice question that gives you only 2 minutes, whereas the other one can be tested in 2 minutes, the superficial mechanical application. And a similar thing in linguistic analysis means explanation. So you can say analysis at a very low level, mechanical level, or analysis at a deep level. Which one?
So in other words, what you're saying is the Bloom's taxonomy verbs are not sufficient, or do not sufficiently articulate the different levels within each of the verbs.
Yeah.
So it is important for the teacher to understand those different levels and design the assessment based on that, not blindly go by the Bloom's taxonomy.
Actually, Bloom's taxonomy is a nice example of superficial analysis. Bloom took a large body of data and labeled them. I don't think he understood the meaning of the word analysis. So
okay, Mo, thanks for that. And that was a great.
You're welcome.
Yeah, thank you. See you.